Welcome back, everyone. Our final session will be led by Jim Newed, Food and Beverage Segment Manager, Motion Division Drives Business, ABB, who will speak about best practices for improving uptime in the food and beverage manufacturing. Many things play into maximizing uptime in the food and beverage facility. Running lean has understandably become the mantra of most manufacturers. The focus needs to be on the core competency of producing quality products. As food and beverage plants become more and more automated, ensuring that processes are efficient, maintained, and repaired when needed is imperative. Learn how the system design impacts uptime, how energy efficiency plays a role, how you can make improvements, and what tools and resources can help you create efficiencies that drive uptime. Jim has worked with manufacturing customers for over 30 years, transforming data-driven automation concepts into sustainable business solutions. As ABB's food and beverage segment lead, Jim leverages his expertise in IIoT, manufacturing execution systems, predictive maintenance, and safety to deliver highly effective automation solutions that increase productivity and profitability. Once again, after Jim has finished his presentation, we will open the virtual floor for questions. As a reminder, if you have any questions during or after the presentation, please post them in the Zoom questions box. Over to you, Jim.
Well, thank you very much. I want to thank everybody for inviting me to participate in this event. I found the previous speakers extremely good, great information, and I hopefully can live up to the precedent that they've already set. So my name is Jim Newed, and I'm going to be talking about the food and beverage industry and how we can improve uptime. My background has been pretty diverse, everything from working at an OEM to doing the system integration, working for other major manufacturing companies in the automation business, been around the world. So this is an exciting business for me, and I'm going to kind of share some of the successes and the things that we're doing now to help move the food and beverage manufacturing industry forward into the future. So this is, I'm going to kind of hit on some topics that I know were already discussed. But anyhow, so I want to talk about best practices for improving uptime. So I'm going to be talking really about three different topics. First thing I'm going to be talking about is proper electrical power supply. If you have electrical problems, you're not going to be making product. Then the next thing is, after you've got a stabilized platform to manufacture, now how do you move from preventative maintenance to predictive maintenance to maximize your equipment uptime? And then the next thing is I'm going to be talking about some of the process efficiencies and things that we've done to help reduce energy. Energy costs are a big deal right now. So, we're talking about from the factory floor to the cloud, how we can keep production running. And we are here to assist you wherever you are in the world. You guys are all in the industry, so I'm not going to talk too much about the demands. You guys are more of an expert in this than I am, but needless to say, factories need to operate 24/7, and they need to operate with higher efficiencies. There's productivity goals, and also sustainability is a big issue today. There are a number of KPIs that the food and beverage industry is focused on. Costs, OEE was discussed earlier today, food safety, the supply chain, quality, power quality, as well as product quality, sustainability, and then a little bit about this industry 4.0 and digitization. Talking about some of the key challenges, the big challenge that everybody's aware of is the impact of food recalls. This is the gorilla in the room. And I wanted to highlight here that, one of the leading causes of food recalls is actually processing defects. So, when you have processing defects, not only do you have an impact to your overall business, as far as the reputation, but also it causes downtimes. And some of these downtimes can be caused because of fluctuations in the power supply. So power disruptions and poor power quality, can directly impact this. So what we want to do is ensure that you've got a high power quality within your plant. Power quality costs over in Europe right now are, costing, billions of euros. Downtime in the industry is expected, is between $100,000 and $1 million per hour, depending on the plant and the size. And you've got also variations in the voltages. And, voltage sags account for 92% of the financial losses. So power quality is very important. And I just want to make this, less of a theoretical discussion. Here's an example we have from the dairy industry. When you manufacture dairy products, temperature is very, very critical to your processing. You go through, homogenization, pasteurization, things like that. And all those need to be done at the proper temperature, as well as the actual bottling, and that needs to be stored and kept at the proper temperature. And so any expected disturbance, can make you have to throw away a perfectly good batch of product. And that is just waste. Any unexpected downtime can cause spoilage, and you can end up having to dump that valuable milk product. So that's lost production time, and as well as the product loss, et cetera. So that's just an example in the dairy industry. So continuous loads for process control are really the issue. And this is applicable for any type of manufacturing. And what's important in here is that you have the proper power protection. And I also recommend that you include something like a UPS on some of these critical systems. The systems that would be directly affected would be, your packing, your picking, your filling, centrifuges, dryers, blowers, mixing operations. Even your control system, needs to be protected. If you don't collect data, you're not going to be shipping product. So control systems, need to have the proper power protection, as well as even security systems need to be protected. One of the issues we run into with power systems is harmonics. And harmonics themselves, they come about from nonlinear loads, and they can affect your motors, transformers, generators in your systems. And I've kind of shown the areas where harmonics can directly impact. What is a harmonic? Well, basically, when you have a regenerative load, or you have a nonlinear load, you're using it typically like this is a 6-pulse drive. And you can see that there's a ripple that's been put onto the power grid. And so the idea here is we want to make sure that we clean up that power. So there are a lot of challenges associated with devices that create harmonics. Now, there's a lot of ways you can correct those harmonics. And some of those are fairly simple. Some of those are more complex. The level of harmonics produced over here on the left axis. So, your most contributor to harmonics would be your 6-pulse and 12-pulse drives. You can put passive filters on those. You can go to your 18-pulse drive, which, has a reduction of harmonics, but it does have complexity. It requires, a lot of extra devices, as well as passive filters require extra wiring and installation costs. So the ULH solution is probably the easiest to install and has probably the lowest cost overall. So what I've done here is I've kind of graphed by the industry the relative product costs and performance for the difference. And you can see that, this cost is taking into account the installation costs as well as procurement costs of the hardware. This ultra low harmonics, there's a number of vendors who produce those. That's really the way to go for this industry. These systems are much easier to integrate into your control systems. A lot of them have support for IoT, your Industry 4.0. You know, the ones that we produce are also designed for any type of motor, whether it's an asynchronous permanent magnet or a synchronous reluctance motor. And the other thing is the ULH, they run a little bit cooler temperature and they've got less maintenance required. So I guess the conclusion of this is, when it comes to harmonics, there's no need to mitigate those harmonics if you put in systems that barely create them to begin with. And there's a lot of benefits as far as paying penalties on your utility bill, working with generators and outside power sources like cogeneration. And it also allows your motors to last longer. And you know, it also will prevent some of those random ghosts that we see sometimes when you get harmonics. The two hardest problems I've found to diagnose in the field have been, you know, ground faults and harmonic disturbances. They're just harder to track down. So the big thing here is, you know, you don't need to worry about mitigating those harmonics if you don't produce them initially. Now we're going to go talk about unplanned downtime. And when you talk about maintenance strategies, we talked about there's, your normal preventative maintenance, and you got, indirect costs and direct costs. And so if you're just correcting what goes wrong, you are going to be probably experiencing some wastage, and you really aren't running as optimal as possible. The better approach really is to go to a time-based maintenance, so that you go and you do your monthly or quarterly maintenance processes, and you can reduce the failures just by having a time-based maintenance, doing the proper schedules. But if you can go to condition-based monitoring, what you can actually do is you can use this data to adjust your scheduled maintenances. And you can also use this as triggers, and it can also provide you additional data for doing root cause analysis. And it allows you then to do some troubleshooting and proactive type maintenance. So the panacea here really is moving to a condition-based maintenance as much as possible. So when we do this condition-based monitoring, we have a platform, we call it the Ability platform. It's an IoT platform, web-based, and I've got some screens basically showing how we can do this from a fleet standpoint, so that you can look at multiple plants, multiple facilities, all brought into one common dashboard. And so alerts and notifications can be done locally, as well as being broadcasted more regionally. And this allows optimization of assets, allows better utilization of spare parts and things like that. And then if you do have a systematic problem that's in more plants, it allows you to visualize what's going on there. So now this data can be everything from medium voltage for a brownfield study here that we did, where we brought this on in, and we're looking at the sensors, at the power coming in to the facility initially, and then also looking at the breakers as they go through the power distribution. And then we can also include things like circuit temperature sensing and things like that, all being brought back. When we move to the plant floor, we can then do the powertrain analysis. And so you've got, going from right to left, I'm going to go backwards here, but your smart sensors on the pumps and devices like that are actually moving the product around. And those can be sensors for vibration, pumping speed, and you can detect things like misalignment or problems with bearings, loose seatings and things like that, all the way to the gearboxes, smart sensors for the bearings themselves. You can look at temperature and vibration and other bearing condition. And then moving on to the motor, smart sensors on the motors can actually tell you if you've got problems with alignment, if you've got motor windings that are running too hot. You can look at the operation hours, the starts, things like that. And, we've actually had some cases where with the smart sensor, we were able to identify some problems early on. In this particular case, the motor was being sent out for rewinding. It came back, it had not been rewound properly. The smart sensor immediately detected that the motor had been reinstalled in a proper way. And we were able to address this. It didn't cause any plant downtime. We were able to shift this to a maintenance period when they weren't running production. And so it saved a lot of money just by being able to detect that the motor was about to fail. And then also we've got condition monitoring for the drives. All this information can be brought through the drive. The drive itself will tell you a lot of the performance behavior that's going on in the motors. It'll actually tell you the energy being used, and it'll be able to tell you the cycle time, the temperatures, as well as give you some good warnings and notifications if there's a problem with the variable frequency converter. So the idea here is to move from condition monitoring to a predictive modeling, and you can look at the overall powertrain health. We can look at a lifetime condition. The graph in the upper right, we actually have plotted out the amount of time that it was running at its preferred operating conditions, and then the amount of time that it was exceeding in the yellow. And then there were actually some times where this powertrain was running at above its optimal condition. We were actually causing some premature damage. You can basically look at it on a calendar view, and you can see whether or not it was running at the proper conditions, with the green, or if there were some issues associated with it, and then they're identified as yellow. So you can actually drill down and find out when this motor and drive were not performing, as designed. And then the last graph is then being able to take this analytical information. We've got the capability to predict what the aging is. And so, we've got the standard aging curve is being shown here in the blue triangle, because this particular, drive that we're using was being well taken care of. We're able to estimate its lifespan and show that, when it needs to have some preventative maintenance done on the drive with the yellow line. And then the red line is basically when the system is going to be needed replaced. So this allows you to move from, your condition monitoring, being able to react, to being able to actually predict when you need to, bring a line down and rebuild some devices. It ends up saving you a lot of money in both by being able to schedule things and understand exactly the health of your devices. And with that, you can also look at your energy. It helps you do the life cycle for the equipment, know when it needs to be refreshed, when it needs to be rebuilt. And, you can look at this in a view where you look at the powertrain as a common an entity, or you can do this on a line or area of the plant. When we talk about energy efficiency and efficient processing next, and these are just some case studies where we've been able to help reduce the costs of the energy and give some extra optimization. We've got a case with Campbell's soup, where we're able to tackle the refrigeration compressors, reduce their energy costs by 14% by running the system at a lower temperature. The system was actually being run harder than it needed to be. And by having the proper data, we could run it at lower temperature. It reduces the vibration and noise. So it just gives it a longer lifespan. We've got some other case studies here where we've been able to reduce the lifespan of or increase the lifespan of the motors and reduce their energy costs. A case with a water pump in the Netherlands, we saved 20%. And then this case over in Sweden, we're able to give an ROI of about 18 months just by including pumps and fans with drives on there. So in short, anytime you have a pump and fan and it doesn't have a drive on there, you're potentially losing energy. It's much more efficient to put a drive on a pump and fan and allow it to operate at the right speed. And it will also just save your energy. As a lot of times you've got mechanical dampeners and things like that involved, or maybe you're running it at too aggressively. And if you ran at a lower constant rate, you actually save quite a bit of energy. Water is a big area when it comes to making food products. Somebody told me once that it takes 30 gallons of water or so to make your large cheese pizza, if you count into all the water that's used in food processing. So, a lot of times if you don't have a good water supply, you're not going to be making your product. And water is one of those utilities that putting a drive package on there, we can definitely enhance the life of the motor and the pump, and save you quite a bit of energy with that. And here's some examples where we've saved energy consumptions considerably. When it comes to some of the packaging and processing here with the chocolate, we're able to save 3 to 4% of their electrical energy just in that process area, and huge reduction in the CO2 emissions over the lifespan. So how do we do this? There's a couple of different ways. The standard motor is what we call an IE1, and there are some IE3 motors that are out there. IE3 motors are probably the typical ones that are used. We do have a new IE5 SynRM motor, and this provides ultra premium level of efficiency. The nice thing about this new technology is it does produce or uses less energy by about 40% than your typical IE3 motor. And that just means that it goes right to your bottom line. The other thing about the SynRM, it does run quite a bit cooler, and we found that it has a longer lifespan, and it is available in stainless steel for sprayed on wash down environments. And we've got a couple of just sort of notes there. ABB was kind of in the forefront of working on the SynRMs. We produced the first one. It was an IE4 back in 2011. It was first just designed for pumps and fans. Now it's available for all applications. And now in 2019, the IE5 ultra premium efficiency motor has been introduced. And so this, is just a graph. This also provides a nice view into the motor itself. You can see that the SynRM's got a new rotor design. And this rotor design was really designed to work with a drive and to maximize the efficiencies. So you can see what the losses are in comparison. Much less loss with the IE5 than an IE3, and of course, even greater than that over an IE1. Some of the other things that we've done, to optimize protection or optimize your production is we've got cavitation detection and control that we can build into the drives themselves. So what we can do is actually looking at the parameters within the drive, we can sense whether or not the pump is starting to cavitate. Cavitation will change the consistency of the product you're pumping. Also, on a kind of a microscopic level, it produces these bubbles, and these bubbles will actually damage the impellers on the motors. So the cavitating a motor is really shortening the life of, or cavitating a pump rather, is shortening the life of your pump. So with this cavitation detection control, we can reduce the variability of your product. This is very good when it comes to dairy. You're not changing the consistency of the product. Like when you take it out of the truck and you're pumping it into your plant, the level of the tanker goes down and the pressure goes down as well. And this will help compensate for that. And it doesn't require any additional hardware. This is all just done by the intelligence within the drive itself. We talked about reducing energy costs with fans. One of the biggest, fans we have in the industry is our cooling towers. And we've got a direct drive motor, that works with one of our drive packages. The direct drive motor reduces the gearbox. Gives you less vibration, less noise, and it's also can provide higher efficiencies. And then one of the other things too with drives is it is possible to take that regenerative energy and push that back into your grid. The way that works is, when you've got a centrifuge which is spinning up, it requires quite a bit of energy. And then once it's completed, it will then start to spin down. To spin that down, we use resistance. We use braking resistors, and that braking resistor generates heat. Well, we can actually capture that energy instead of going through a braking resistor and put it into the next drive. And so the concept here is that as the one centrifuge is spinning down, it's providing the energy to start up the next centrifuge. So this is a great way to save energy. You're capturing energy that would have been lost as heat, and you're putting it back in your process. The regenerative drives are ultra low harmonic to begin with, so they do work great if you've got a cogeneration type facility. A lot of times we see that with sugar processing, where they will have connection to the grid, but they also produce their own energy, and not having, cogeneration doesn't like harmonics. Let's just put it that way. So it is very generator friendly and also works well in a cogen type scenario. So I know that was a lot of information. I just want to give you a quick overview of some of the things that are being used, and the key values of what we provide are really to help you have continuous operation, do it in a cost-effective manner, help with your food safety and quality, and help with your energy efficiency. And ABB is available. We operate in 100 countries, and we're available around the world. So if you have any interest or further questions about ways we can optimize your energy, your predictive maintenance plans, and moving that to Industry 4.0, or some of these features that I've talked about, don't hesitate to call me. And I just want to thank you guys once again for a great session here and being included in this. And like to thank our hosts, Mario, you've done a great job pulling this all together.
All right, thank you very much, Jim. Lots of great technical information. And once again, we have some time for Q&A. We're just looking at some of the questions that have come in. Let's start with, how do the drives handle a situation with cogeneration or backup generators?
Well, I kind of alluded to that cogeneration, means that you've got multiple energy sources, and generators themselves don't handle harmonics. The other thing too is cogeneration does not like a leading or lagging power factor. It really prefers to have a unity power factor. And that is another large feature of the ultra low harmonic drives, is they do provide a unity power factor throughout the power range.
Right. Our next question. What is the cost for condition monitoring and smart sensors for motors and drives?
Oh, well, it varies. Anytime you kind of put on the spot with a question of of costs, got to be kind of a little bit careful here. But I would say, for a motor, there are motor sensors in the $300 to $600 range. Those don't require any additional, features to mount. A lot of times they will mount into a hole that's already provided there, in the motor itself and also in the bearing. So it's I would say the $300 to $700 that's US dollar price range.
Okay. What are the networking infrastructure requirements for deploying your IoT solution?
That's a good question. Okay, so typically with the Industry 4.0 and the IoT solutions, we found it kind of a best practice not to put that data on the same network that you've got with your production. So the tendency right now is to have a parallel network that would then be providing that information, to the cloud or whatever. So that can be rather expensive. Having done a lot of Industry 4.0 projects, sometimes the infrastructure costs exceed the cost of the equipment. Especially you've got to run, fresh Ethernet and all the networking equipment to support an IoT network. And in the case of these sensors, these are actually Bluetooth enabled, and so they communicate to a Bluetooth gateway, so they don't require any additional infrastructure. And we do have a new version that's coming out that is it uses a cellular type broadcast, so it requires not even the Bluetooth network. The gateways are really used to consolidate the information, and then those are aggregated and then pushed up to the cloud. And that can be done, in a cloud version, like I showed you for fleet management, or it can also be done on premise. Of course, there are capabilities with, the SDIs, the interfaces and things like that, to pull the data into your control platform as well. Especially if you've got a controller that leverages like a Codesys platform or something like that.
All right, and we got time for one more question. How do you handle situations where the motors are located a long distance away from the drive's power source?
Okay, this is a real big problem. The drives typically are designed to produce a fixed voltage at the terminal of the drive itself. Sometimes when you put in filters or you use other strategies, you actually can lower that voltage that's available at the drive terminal. Then compound that with the long motor lead lengths. Then what you've got is a situation where you've reduced the motor voltage considerably, especially when you're talking about 50 meters or so distance that you have to run your cables from the drive to the motor. The ULH that we have has some unique technology where we ensure that you get 98% of the full motor voltage is available at the motor, and that's compensated through the DC bus structure that we have. And so not only does that DC bus provide you unity power factor, but also provides you with full motor voltage. if you don't get full motor voltage, the problem is that, if you reduce voltage, the current goes up. And so when the current goes up, you get extra heat, you reduce the lifespan of your motor. So that's the bottom line, is you want to make sure you get, the full motor voltage out there.
Right, lots of great answers. Thank you once again, Jim, for a very informative session.
Thank you.